How's it going, everybody? In this video, we are going to go over the LeetCode problem, climbing stairs. So this is a really useful problem to go over if you have never done dynamic programming before. This is like the most basic level of dynamic programming. Before we get started, I want to let you know about my technical interview prep platform, AlgosWithMichael. If you are preparing for coding interviews, I highly recommend checking it out. So this platform is different from other coding prep websites because I teach you the patterns to solve various categories of interview problems, such as sliding window, top K element, and binary search. Learning these patterns is literally like having a cheat sheet because you will know exactly how to approach the problem based on the type of problem it is. And also, just for my YouTube audience, you guys get a discount using the code ALGOHELP. So back to the problem, the description says you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So in this first example, n equal to 2, the output would be 2. And this is because there are 2 ways to climb to the top. So if n was equal to 2 and we had 2 steps, right? Our goal is to get here. We could go 1 step and then 1 step, or we could just go 2 steps to the top. So, you know, that's 1 way and then 2 ways. 2 would be our answer for this input. And the second example, n equal to 3. So if n is equal to 3, we would have 3 stairs, right? And we want to get to the top here. So we could do this in 3 different ways, actually. So the first way is we could just go 1 at a time. So we would go 1, 1, and then 1. So that is just 1 plus 1 plus 1, and that equals 3. That means we made it to the 3rd step. The other way is we could go 1 step and then 2 steps, right? So that would be 1 plus 2, and that also equals 3. And then the last way is we could go 2 steps and then 1 step. So 2 plus 1 equals 3. So in total, there are 3 different ways that we could get to the 3rd step by going only 1 or 2 steps at a time. So for this problem, we're going to be doing a bottom-up approach. And what this means is that we are going to calculate the answers for essentially our base cases. So our constraint says that n can be between 1 and 45. So if n is equal to 1, what would be our answer? It would just be 1, right? Because if we were trying to get to the top of just 1 stair, we can only get to that stair in 1 way, which is just by going up 1. And then when n is equal to 2, we can get to the 2nd stair in 2 ways, like we've already gone over. And then n equal to 3, like we've already gone over, we can get to it in 3 different ways. Let's calculate what n equal to 4 would be. So we could do that by going 1 step at a time. So we could just do 1 plus 1 plus 1 plus 1. We could also do 1 plus 1 plus 2. We could do 1 plus 2 plus 1. And then we could do 2 plus 1 plus 1. And then finally, we could do 2 plus 2. So in total, there are 5 different ways that we could get to the 4th stair by going 1 or 2 steps. So when n is equal to 4, we would return 5. Now, what I want you guys to notice is that we are building off of previous results that we've already calculated. And that's kind of the core concept of dynamic programming. You're just building off of previous calculations. So notice at n equal to 3, you can see that we're just summing up the previous 2 steps. So all we're doing is we're doing 1 plus 2, and that equals 3. Right? We're just doing the sum of the previous 2 steps. Or when n is equal to 4, we're doing 3 plus 2, right? And that equals 5. So since we calculated our base case answers when n is equal to 1 and n is equal to 2, we can always know the answer for any n number by just building off of the previous calculations. So with that in mind, n equal to 5, right? All we would be doing is 5 plus 3. So we would have 8. And then n equal to 6, we'd be doing 5 plus 8, which is 13. And we can keep on doing this for however many steps that we want to compute.
All right, so let's go over the code for this solution. We are given an integer n, and we need to return an integer which represents the distinct ways that we can get to the top. So first we want to handle our base cases. So when n is equal to 1 or n is equal to 2, right? So we could have a conditional here that says if n is less than or equal to 2, then just return whatever n is, right? Because if n is equal to 1, then we return 1. If n is equal to 2, then we return 2. And now we need to actually start our dynamic programming algorithm. So we could say int first is equal to 1, and then second is equal to 2, right? Because these are our base cases, 1 and 2. And now we need to start looping starting from 3 up to whatever n is, right? And the next step is going to be calculated by just doing first plus second, right? And then we need to reassign our variables. So our first variable is going to become our second, and then our second is going to become our third, right? And then we just need to return the second variable. So let's make sure that this works. Let's submit, and there we go. So our time complexity for this solution is going to be big O of n, where n is our input, and our space complexity is constant because we're only initializing variables here. So that is how you solve the problem, climbing stairs. I hope this was helpful for you guys. This is a really good introductory problem to dynamic programming. I'm going to be releasing a lot more dynamic programming related videos, so definitely subscribe if you want to get notified for those videos. And also check out my platform, AlgosWithMichael, if you want to learn the patterns to solve a bunch of categories of interview problems. And with that, I'll catch you guys later.